we are going to see the collisions today. Suppose we have these two bodies colliding with each other. Okay, so suppose there are these two masses, they are moving in a straight line for simplicity. So this mass m2 is moving with speed u2 and mass m1 is moving with speed u1, right? So for these two masses to collide, u1 must be greater than u2, right? u1 must be greater than u2. So now there are two types of collision. One is elastic collision, one is inelastic collision. So what happens in case of the elastic collision is the total momentum before the collision is equal to total momentum after the collision, and also the total kinetic energy of these two masses before the collision is equal to total kinetic energy after the collision. Okay, so total momentum before collision is equal to total momentum after collision. Total kinetic energy before collision is equal to total kinetic energy after the collision. So both the momentum and the kinetic energy is conserved in case of elastic collision. Now momentum is also conserved in case of inelastic collision. Okay, so total momentum before collision will be equal to total momentum after the collision also, but the kinetic energy is not conserved. Okay, so total kinetic energy before collision is not equal to total kinetic energy after the collision in case of inelastic collision. So that means some energy is lost. Okay, some kinetic energy is lost in case of an inelastic collision. Okay, so now what is a perfectly elastic collision? Momentum is conserved, kinetic energy is also conserved, and we are going to see a term called as coefficient of restitution. So coefficient of restitution is denoted by letter E. Okay, we are going to see what is that. So E is equal to 1. Okay, so for now let's just remember this, that E is equal to 1. That means coefficient of restitution is equal to 1 in case of perfectly elastic collision. Then just to give you an example, example is collision between two subatomic particles. So we can say it is a perfectly elastic collision. Then what is perfectly inelastic? Momentum is conserved here also, kinetic energy is not conserved, and E is equal to 0. So we are going to see what is E. E means coefficient of restitution. And for an example, the lump of mud falling on the floor. Okay, so what happens in case of perfectly inelastic collision is the two bodies collide and stick together. Okay, so suppose for an example, one body is moving in this direction and another body follows and it hits the first body. Okay, for an example, suppose there is an wooden block. Okay, and suppose the wooden block is it is oscillating. Okay, so suppose you hang that wooden block from the rigid support and it's oscillating like this, and you fire a bullet, then a bullet hits the wooden block, it gets embedded in it, okay, and it moves along with it. So that is perfectly inelastic collision, right? So two bodies, they stick together or get embedded and move together after the collision. Okay, so perfectly inelastic collision. Then now most of the collisions in the real life, they are in between perfectly elastic and perfectly inelastic. So momentum is conserved there, kinetic energy is not conserved, and this thing called as coefficient of restitution will be in between 0 and 1. Okay, so for perfectly elastic it is 1, perfectly inelastic it is 0. So for most of the collisions it will be in between 0 and 1. Okay, for an example, the collision between two vehicles, it is inelastic collision, but it may not be perfectly inelastic because two vehicles collide, but they don't, most of the times they don't stick together, right? They move in different directions. Okay, so is this thing clear, everyone? So after that, let us talk about the perfectly elastic collision. So we have two conditions. One is the momentum is conserved, one is the kinetic energy is also conserved, right? So suppose these are two bodies, okay, and mass of second body is m2, its speed is u2, they are moving in a same straight line. Okay, so this first body having mass m1, it follows the second body and it hits the second body. Okay, so with speed u1, then So total momentum is conserved and total kinetic energy is also conserved. So for momentum conservation, we can say that total momentum before collision, it is m1 u1 plus m2 u2 is equal to total momentum after the collision. So suppose speeds after collision become v1 and v2 for the first body and the second body. So total momentum is m2 sorry m1 v1 plus m2 v2, right? And then from there what we can say is that we can take terms containing m1 on one side, terms containing m2 on other side. So you get m1 u1 minus m1 v1, okay, is equal to m2 v2 minus m2 u2. Then you can take m1 common. If you take m1 common from these two, then what remains is u1 minus v1. Similarly, if you take m2 common from here, what remains is v2 minus u2, okay. So that is your equation 1, suppose, right? Then conservation of kinetic energy. So we have half of m1 u1 square plus half of m2 u2 square is equal to half of m1 v1 square plus half of m2 v2 square, right? And then again what we do is take terms containing m1 on one side, terms containing m2 on another side. So then after simplification, so what you have is you can cancel out half, then you have m1 u1 square, then minus m1 v1 square is equal to m2 v2 square minus m2 u2 square, okay. Alright, then you can take again m1 common from left hand side, m2 common from right hand side, then you get m1 multiplied by u1 square minus v1 square is equal to m2 multiplied by v2 square minus u2 square, and then you can simplify this one, okay. So you can write this thing as using the a square minus b square formula, a minus b, a plus b. So here you can write u1 square minus v1 square is equal to u1 minus v1 multiplied by u1 plus v1. Similarly, this thing can be written as v2 minus u2 multiplied by v2 plus u2, and then you cancel out this thing, because see, equation 1 says that m1 multiplied by u1 minus v1 is equal to m2 multiplied by v2 minus u2. So you can cancel out m1 times u1 minus v1 is equal to m2 times v2 minus u2 from equation 1. Then what you get is u1 plus v1 is equal to u2 plus v2. Now this equation is one that we can remember, okay. u1 plus v1 is equal to u2 plus v2, right? So this is for the case of perfectly elastic collision, okay. So now see, you can write u1 minus u2 is equal to v2 minus v1, okay. u1 minus u2 is equal to v2 minus v1. So now here comes the definition of the coefficient of restitution. What is that? So coefficient of restitution means velocity of separation minus the velocity of approach, okay. So what's that? So what is velocity of approach? So both of these bodies are moving, okay. m1 is moving, m2 is also moving, but m1 is approaching closer to m2. So if m2 was not moving, then we could say that it was m1 was approaching m2 with speed or with velocity u1, right? But because m2 is also moving, then we need to take relative velocity, okay. So relative velocity of between these two bodies would be equal to what? u1 minus u2. So that is velocity of approach, u1 minus u2, okay. So that is just velocity of the body which is following the another body minus the velocity of the body that is being followed, right? So that is velocity of approach. And then there is velocity of separation. So after the collision, two bodies will separate from one another, okay. So this body, second body, suppose it moves ahead, and again the first body, it will follow. So second body separates from the first body with some velocity, and again we need to take the relative velocity, and that's why it will be equal to v2 bar minus v1 bar, v2 minus v1, okay. And then what is coefficient of restitution? It is the ratio of velocity of separation to the velocity of approach. So that is E is equal to v2 minus v1 divided by u1 minus u2. This thing is clear, everyone? Is the definition clear? Right. Okay. So now this coefficient of restitution in the case of perfectly elastic collision, is equal to 1. So we just found that u1 plus v1 is equal to u2 plus v2. Okay, then we can move this u2 on this side and v1 on that side. So you get u1 minus u2 is equal to v2 minus v1. u1 minus u2 is equal to v2 minus v1. So if we divide v2 minus v1 by this thing, u1 minus u2, what do we get? We get 1. So that means the coefficient of restitution in case of perfectly elastic collision is equal to what? It's equal to 1. Okay. So this thing we need to remember. Okay, for perfectly elastic collision, the coefficient of restitution is equal to 1. Right. Then after that what we do is we take this formula, okay, this one, or you can say this one, and from that what we do is we find out v1 in terms of v2, okay, or v2 in terms of v1, and we substitute that in this one in the formula of conservation of momentum, linear momentum, and then we solve that. See, what we do is we take this thing, this relation, okay, which we found using the two conditions, okay, conservation of momentum and conservation of kinetic energy. We take that relation and we put it in conservation of momentum relation. Okay, so see, we put in place of v2 we put u1 plus v1 minus u2, which comes from here, okay, which comes from here, and then what do we get is, finally after some simplification, we get v1 is equal to, v1 is what? The velocity of first body after collision. It's equal to m1 minus m2 divided by m1 plus m2 times u1 plus 2m2 divided by m1 plus m2 times u2. Okay, and v2 is equal to, this is velocity of second body, it's 2m1 divided by m1 plus m2 times u1 plus m2 minus m1 upon m1 plus m2 times u2. Okay, so now these two formulae you need to remember. Okay, so velocity of first body after collision is m1 minus m2 divided by m1 plus m2 times u1 plus 2m2 upon m1 plus m2 times u2. And now suppose somehow you memorize this one, okay, or you remember this one and you cannot find out the other one, then what can you do is just replace m1 and m2, just interchange them, and u1 and u2. So from here you will get the second formula. Okay, so to get v2, what you need to do is just change v1 to v2. Okay, left hand side will be v2, and then interchange m1 m2 and u1 u2. So from this formula you will get this formula. This thing is clear, everyone? Yes, no? Right. Okay, so now you need to remember this formula. Okay. So then there are few special cases like suppose m2 is far greater than m1 and u2 is equal to 0. Okay, an example of this is m2 is far greater than m1, means for an example there is a wall. Okay, so the mass of wall is far greater compared to, suppose second body is a ball. So you take a ball and you hit it on a wall. What will happen? Nothing will happen to the ball, but the ball will bounce back with the same speed, right? Yes, no? Okay, so see, mass of the second body is far greater compared to mass of first body, and speed of it's equal to 0. Okay, so if you substitute that, so mass of second body is far greater compared to mass of the first body, then see, in this formula we can just neglect mass of the first body. If we neglect that, then what do we get is minus m2 upon m2. So m2 by m2 gives you 1, so minus 1 times u1. Okay, and in this one we considered u2 is equal to 0, so u2 is 0, the second term will become 0. Okay, then you get, see, minus 1 times u1 means minus u1, and this thing will be 2 times m2 by m2 is equal to 1, so 2 times u2. So if you take u2 equals to 0, so this second term will be equal to 0. So then you get what? v1 is equal to, it is nearly equal to minus of u1, right? v1 is nearly equal to what? Minus of u1. So the ball hits with the wall and it rebounds, okay, with the same speed, right? And what happens to, so if mass of second body is far greater compared to mass of first body, then nothing happens to the second body, right? So suppose second body is moving with some speed, so then what do you get? So again what you do is you neglect m1, okay, so it is 2 times m1, you neglect that, so this is almost equal to 0 because mass of first body is very small compared to the mass of second body, so this term is neglected, and then you get m2 minus m1 divided by m1 plus m2. Again you cancel out m1, I mean you neglect m1, so m2 by m2 is 1, v2 is just nearly equal to u2. Okay, so nothing really happens to the second body, right? This thing is clear? Yes, no? Okay, so this is like a common sense, but we are just checking it using the formulae, right? All right, then second special case. So second special case is if m1 is equal to m2, then what will happen? So if m1 is equal to m2 is equal to m, then m1 minus m2 is equal to what? It's equal to 0. Then what will be v1? So v1 is equal to, this first term vanishes because m1 minus m2 is equal to 0, and in the second term you have 2 times m divided by m1 plus m2 is also 2 times m, so that's 2m gets cancelled out, so you have 1 times u2, so v1 becomes u2, and similarly v2 will become u1. So what happens if two bodies having same mass collide with each other elastically? Okay, this term is important, elastically. So two bodies hit with each other elastically, then if their mass is same, then velocities get interchanged, velocities are exchanged. Okay, so velocities of identical bodies are exchanged in perfectly elastic collision. Okay, so this thing we need to remember, that velocities of identical bodies are interchanged. Okay, so this thing is clear? Yes, no? Right. So just to give you an example, so if you have seen the game of pool, okay, or snooker, then in case of snooker, what you do is you hit one ball with a stick, then that ball hits with another ball, okay, which is at rest, and most of the times you will see, because their masses are equal and collision is nearly elastic, you can say, so the ball that's hitting the another ball, it stops and the another ball moves ahead with the same speed, right? Another example is in case of carom. Okay, you hit the striker, then that striker hits another coin. Okay, striker will cover some distance and stop. Okay, but the coin, another coin, that coin hits another coin. Okay, the coin that you hit with the striker, it hits another coin, so that coin stops and another coin will move ahead. You see that in the game of carom, right? Okay, so this is very common. Okay, so these are some examples of nearly perfectly elastic collisions. Okay. Alright, so this is perfectly elastic collision. What do we need to remember? This thing we need to remember coefficient of restitution is equal to 1. The total momentum before collision is equal to total momentum after collision. Total kinetic energy before collision is equal to total kinetic energy after collision, and also coefficient of restitution is equal to 1. Okay. So now let's see some examples based on the perfectly elastic collision. The coefficient of restitution E for a perfectly elastic collision is, now this is very simple. Okay, so they might ask this question. So answer is what? Answer is 1. Okay, good. Let's see next one. A rubber ball is dropped from height of 5 meter on a plane. So rubber ball is dropped on a plane. On bouncing, it rises to 1.8 meter. So it bounces back to 1.8 meter. The ball loses its velocity on bouncing by the factor of. This is the question. So how do we solve this? The ball, now this is very simple one. The ball falls from some height, okay, on the floor. How much height? 5 meters. So it hits with some velocity. Okay, so let's say it hits with velocity u. U is equal to what? Square root of 2g h1. So this height is h1. Okay, and it bounces back to some height. So it goes till this height, let's say h2. So v would be equal to square root of 2g h2. Okay, it comes with some velocity, it bounces back with some velocity, so that velocity will be equal to what? Root of 2g h2, right? So the ball loses its velocity on bouncing by the factor of. So what's the question? So suppose initial velocity is u, final velocity is v. Okay, so change in velocity, delta v is equal to what? It's equal to u minus v. But this is not the question. They are asking what is the fraction, right? The ball loses its velocity on bouncing by the factor of. So this is delta v. You need to find delta v divided by initial speed. Initial speed is u. U minus v divided by u. Okay, so if we divide this, we'll get 1 minus v by u. Now let's just put the values, right? Let's just put the values. We get 1 minus square root of 2g, that is v, no? So h2 divided by 2g h1. So 2g and 2g gets cancelled out. Square root of h2 by h1. So what's that? 1.8 divided by 5, right? 1.8 divided by 5. Okay, so that is equal to 1 minus 1.8 divided by 5. No, root of that. Okay, so if we multiply and divide by 5, what do we get? 1.8 times 5 is 9, right? It's 9. Okay, so it is 3 by 5, right? I mean, this is 1.8 times 5 divided by 25. Okay, so this thing is equal to 9. 9 divided by 25, root of that is 3 by 5. So 1 minus 3 by 5, that's the answer. 1 minus 3 by 5 means 2 by 5. So it is option B. Okay, this one is clear. Very simple question, right? Okay, then let's see next one. But see here, 2 by 5 is present in the options and 3 by 5 is also present, right? So if we just find out final to initial velocity, we'll get 3 by 5, but that's not the answer. We want back how much factor does it lose its velocity. So it's 2 by 5. Okay. Okay, let's see next one. This is from NEET 2019. A body of mass 4m moving with speed u collides with another body of mass 2m at rest. The collision is head-on and elastic in nature. after collision the fraction of energy lost by the colliding body A is. How much of energy is lost? This is the question. So tell me, this is similar to last one. In last one they had asked what is the fraction of ball loses its velocity. Okay, so fraction of velocity lost, and in this one they are asking fraction of energy lost. Okay, so body of mass 4m moving with speed u collides with another body of 2m. So you can find out initial kinetic energy of first body, because we want to find out the fraction of kinetic energy lost by first body. So initial Ke, okay, let's say E of A, but we want initial, no? So let's suppose that it is for A only, and E initial, or let's write K initial, okay, Ki for A, let's put suffix A, it's equal to half of mass of A multiplied by speed of A, initial speed of A square. How much is that? Half of mass of A is 4m, right? Initial speed is u, so 4m multiplied by u square. Okay, so this is initial kinetic energy. What's final kinetic energy? So final kinetic energy of A, Kf of A is equal to half of mass of A multiplied by the speed of A, final speed of A square. Tell me what's the final speed. So here now, if we remember the formula, we can directly write down what's that. It's m1 minus m2 divided by m1 plus m2 multiplied by u. That's the final speed, because second body is at rest, right? Second body is at rest. Okay, this thing is clear? Yes, no? What's the complete formula? m1 minus m2 upon m1 plus m2 times u1 plus 2m2 divided by m1 plus m2 plus 2m2 upon m1 plus m2 multiplied by u2. But second body is at rest, so we can forget about the second term. Okay, so that is just equal to sorry, m1 is 4m, m2 is m, 2m, not m, 2m divided by m1 plus m2 is 6m multiplied with u1. So u1 is what? U. Okay, so that is 4m minus 2m is 2m, 2m divided by 6m is 1 by 3, 1 by 3 times u. It is 1 by 3 times u. Okay, so speed becomes 1 by 1/3, right? So here, even if we don't substitute ma, that's fine. So let's write ma over here. So final kinetic energy is half of ma multiplied by Va is 1/3 of u, and you have square of that. But what do you want? You want the fraction of the kinetic energy lost, right? Fraction of kinetic energy lost. So this thing minus this thing will give you the kinetic energy lost divided by the initial kinetic energy is the fraction. So what will that be equal to? Tell me. Speed becomes 1/3, means kinetic energy becomes what? 1 by 9. Okay, so the lost kinetic energy, kinetic energy is lost by the fraction of 8 by 9. That is the answer, right? Yes, no? Ke, initial Ke minus final Ke, initial Ke of A minus final Ke of A divided by initial Ke of A. So this is delta K by K. Okay, that is half of mass of A multiplied by u square minus half of mass of A multiplied by u by 3 square divided by, you have mass of A, sorry, half of mass of A multiplied by u square. So half mass A you can cancel out everywhere. Okay, what remains is u square minus u by 3 square. So that is u square minus u square by 9 divided by u square. Okay, so u square is cancelled out everywhere, and this is 1 minus 1 by 9 means it is 8 by 9. So that's the answer, right? Okay, so you can simply say that speed becomes 1/3, so kinetic energy becomes 1 by 9, but that means by what fraction it has lost its kinetic energy? 8 by 9, because kinetic energy has become 1/9, so it loses the kinetic energy by the fraction of 8 by 9, right? Instead of doing all this, you can just do it in your mind. So answer is option C. This thing is clear? Yes, no? Okay, everyone? Good. All right. So this is a simple question, right? Now, if we don't remember these formulas, still we can solve the questions. Okay, but it might take little bit more time. Okay, let's see next one. A moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. Okay, when initial velocity of the lighter block is v, then the value of coefficient of restitution E will be. Tell me. What will be coefficient of restitution? This is the question. Moving block, one block is moving, having mass m collides with a stationary block of mass 4m. This has mass m, this has mass 4m, and then the lighter block comes to rest after the collision. This one stops after collision. This one stops, v is equal to 0, or let's say v1 is equal to 0, and second one moves with velocity. Okay, second one moves with some velocity, right? So v2 is equal to something. Okay, so what is the coefficient of restitution? So u is equal to, it's given u is equal to v, right? Or u1 is equal to v, u1 is equal to v. So now this one we can simply solve using the conservation of momentum. Okay, because see, normally what we need to find out? We need to find out the velocity of first body as well as velocity of second body. But if so, for that we need two conditions. Okay, what are the two conditions? One is the conservation of momentum, one is the conservation of kinetic energy. Okay, and from that we have that formula, v1 is equal to m1 minus m2 divided by m1 plus m2 times v1. Okay, plus 2 times m2 upon m1 plus m2 times v2, right? But this one, in this one, two conditions are given. Okay, masses are already given, and one more condition is given, that the first body comes to rest after the collision. So this one is simple, right? So we can just say the total momentum before collision, m1 u1 plus m2 u2, is just equal to m1 v1 plus m2 v2, and we just need to find out what is v2. Okay, so this thing becomes 0 because v1 is 0, and this thing is 0 because u2 is 0. Okay, so put the values. What is m1? It's m. What is u1? u1 is v, and it's equal to m2 is 4m times v2, and from that you can find out v2. So v2 is equal to v by 4. Okay, option B. Let's check. What is E? E is equal to v1 minus v2, v2 minus v1 divided by u1 minus u2. Okay, so that is just because v1 is 0 and u2 is also equal to 0. So v2 upon v2 divided by u1, and you want v2 upon u1, so that is just equal to, okay, v2 divided by v, so that's 1 by 4. Okay, 1 by 4 is the answer. That means 0.25. Correct. It's option B. Right, this one is clear, everyone? Okay, can you tell me why it can't be an elastic collision?
E is not equal to 1.
E is equal to 1 for elastic. Yeah, that is one example. Very good. E is equal to 1 for elastic. E is less than 1. Yeah, very good. It is not elastic. Yeah. One more thing. Even before checking that, we can just say that it's not elastic. Why? Because, see, in case of elastic collision, if two masses are equal, then what happens? The speed becomes interchanged. Yeah, one body comes to rest. That can happen in elastic also. But when will it happen? When masses of two bodies are equal. So, first body was at rest, second body had some speed, then the speed is interchanged. Right? Okay, but that will happen when the masses are equal. Okay, so here that first body is stopping and second body is moving, right? Okay, so even before checking what's the speed of second body, we can say that first body comes to rest. That means its velocity has become 0. Second body was at rest. Okay, but if masses are equal, then only it happens in case of elastic collision. Right? This thing is clear. Okay, so this is not elastic. All right, good. So this is inelastic collision. Okay, let's see next one. So directly based upon that, two identical balls A and B having velocities of 0.5 meters per second and minus 0.3 meters per second respectively collide elastically in one dimension. The velocities of B and A after the collision respectively will be two identical balls. Okay, tell me what's the answer? Two identical balls A and B having velocities. These are the velocities. Option B. So it is 0.5 meters per second. Velocities of B and A. Okay, they have changed the order, no? Yeah, that's correct. Option B is the answer. Right? Yeah, good. Everyone? Okay, velocities are just interchanged. So they asked it 3 times and we could have 3 separate questions, but we have only one, right? Because they didn't even change the values. Okay. All right, let's see next one. Two particles A and B move with constant velocities v1 bar and v2 bar. At the initial moment, their position vectors are r1 bar and r2 bar respectively. The condition for particles A and B for their collision is, okay, which one is correct out of these? So how do we check that? This is from 2015. Okay, so see, let me explain this one, because this is not a direct question, right? So when two bodies collide, what will be the final position vector? I mean, when they collide, their position vector will be equal, right? Initial position vectors are different, but when they collide, their position vector will be equal. They meet at one point, right? So suppose r bar is the position vector when the bodies collide. When bodies collide. Right. So now for first body, what can I say about this position vector? So first body had initial position vector r1 bar and velocity vector is v1 bar. Okay, so I can say that this final position vector is equal to initial position vector plus velocity into time plus v1 into t, right? Can we say that? Yeah, tell me. Okay, we can say that, right? Final position vector is equal to initial position vector plus velocity into time. Or if you want to see it in different way, then I can just say that velocity is displacement divided by time. So that is final position vector minus initial position vector divided by time. Okay, divided by time. Then you can move the time on other side. Okay, so v1 times t is r bar minus r1 bar, right? And therefore I can say that r bar is equal to r1 bar plus v1 into v1 bar into t, right? So we can write from this one, we can write this equation. Similarly for second body, I can say for second body it's option C. Okay, let's check. For second body you can say r bar is equal to r2 bar minus, not minus, plus v2 times t. Okay, so position vector of first and second will be equal. So just equate this one and this one. This is suppose equation 1, this is equation 2, right? So from 1 and 2 you can say that r1 bar plus v1 bar times t is equal to r2 bar plus v2 bar times t. Okay, and then from, see here in two options you have r1 bar minus r2 bar and v2 bar minus v1 bar or v1 bar minus v2 bar. What you do is you move this r2 bar on this side. What you get is r1 bar minus r2 bar is equal to, take v1 into t on other side, so v2 bar times t minus v1 bar times t. Okay, so then you can take t common from there. You can take t common, so you have r1 bar minus r2 bar, r1 bar minus r2 bar is equal to, I will take t common, multiplied by v2 bar minus v1 bar, v2 bar minus v1 bar. Okay, still nowhere close to the any one of the options, right? Then what we can say is, see this vector is equal to something, some constant multiplied by this vector, right? This vector is equal to some constant multiplied by this vector, and therefore you can say that this vector and this vector are parallel to each other, and if two vectors are parallel, then their unit vectors are equal, right? Unit vectors are in same direction. So if two vectors are parallel, then their unit vectors are equal. Right, and therefore what you can say is r1 bar minus r2 bar divided by its magnitude, the magnitude of r1 bar minus r2 bar, and that's equal to v2 bar minus v1 bar divided by magnitude of v2 bar minus v1 bar. Okay, so this thing is clear, everyone? Okay, so this is the answer. So Vishalini said option C, right? It's option C. So this is how you solved Vishalini, or some other method? Okay, good. So this is not, what I can say is, direct question or straightforward question. You need to think a lot. Okay, so this is good question. I mean JEE level question. Okay, let's see next one. A ball is thrown vertically downwards from a height of 20 meters with initial velocity v0. So ball is thrown downwards with initial velocity v0. It collides with the ground, loses 50% of its energy, in collision and rebounds to the same height. Okay, the initial velocity v0 is, this is the question. So ball is thrown with some velocity, collides with the ground, loses 50% of its energy. Okay, so now when it just rebounds, what would be its energy? 50% of the energy with which it was thrown, right? So you can say energy of rebound is just equal to 50% of, means half of, energy with which it was thrown. So initial energy. Okay, so initial energy. So energy with which it rebounds is 50% of initial energy, that's clear, but it goes to the same height. This is given, it goes to the same height. So now whatever is kinetic energy of rebounding, it's equal to potential energy of at that height h, right? So you can say that it's equal to just mgh. Okay, and it was dropped from the same height. So its potential energy was mgh and its kinetic energy was half of m into v0 square. Okay, this thing is clear, everyone? Right? So then you can move this 2 on this side. So we have 2 mgh is equal to mgh. 2 mgh is equal to mgh plus half m v0 square. You can cancel out m. Okay, move this gh on that side. So again you have 2gh minus gh is equal to gh is equal to half of v0 square. So again move 2 on that side. Okay, so you get basically what v0 is equal to root 2 gh. Okay, or let me do that. So 2 mgh minus mgh is equal to mgh, that's equal to half of m into v0 square. Move this 2 on this side, cancel out m and m. So you get v0 square is equal to 2gh. That means v0 is just equal to square root of 2gh. This is the answer. But the initial height is given, so 2 times 10 multiplied by initial height, right? G is 10, initial height is 20. Okay, option D, right? So it's 20 times 20, square root of that is 20. So answer is 20 meters per second. Okay, so this is simple, right? Okay, let's see next one. On a frictionless surface, a block of mass m moving at speed v collides elastically with another block of same mass m initially at rest. After collision, the first block moves at an angle of theta to its initial direction and has speed v by 3. The second block's speed after the collision is, so what's given, that on a frictionless surface, block of mass m collides elastically. Okay, it collides elastically with another block of the same mass which is initially at rest. Okay, same mass which is initially at rest. After collision, first block moves at an angle theta. Okay, first block moves at an angle theta to its initial direction and has speed v by 3. The second block speed after the collision is, tell me. So this is simple. See, this seems to be two-dimensional collision. Okay, but what is asked is not the velocity. We just want speed of second block. Okay, so we have initial kinetic energy of first block. So we can say half of m1 into u1 square plus half of m2 u2 square is equal to half of m1 v1 square plus half of m2 v2 square. Why? Because this is an elastic collision, and we know in case of an elastic collision kinetic energy is conserved, right? Kinetic energy is conserved. So half of m1 u1 square. So this thing is 0 and it's given that masses are equal. So mass is m only. So you can just cancel out half m, half m, half m everywhere because mass is equal, right? So let me just cancel out half m everywhere, and the second term, this thing is equal to 0 because u2 is equal to 0. Okay, and u1 is equal to v. So you can just say that v square is equal to v1 square plus v2 square, but v1 is given to be equal to, after the collision, first block only, right? First block only, v1 is given to be equal to v by 3. So v by 3 square plus v2 square. Okay, u1 is v, v1 is v by 3, and we just want, we just want v2. So v2 would be equal to what? Just move this thing on other side. So v2 square is equal to v square minus v by 3 square. Okay, v square minus v by 3 square, that is v square by 9, right? That is 8 by 9 of v square. This is v2 square, and therefore what is v2? Square root of that. So square root of 9 is 3 times v. Okay, and in numerator you will have square root of 2, that is square root of 4 root 2. Okay, square root of 4 into 2 inside a root, and square root of 4 is 2, so it will be 2 root 2, right? 2 root 2. So that's the answer. It's option C. Okay, so Vishalini already said it's option C. So this is simple, very simple, right? Okay, this just follows from the definition of elastic collision, right? So now you might say that we didn't use that formula of final velocity in most of the questions. Somewhere we used, okay, but we need to remember because we don't know whether we will need to use it or not. All right, so these are some examples on elastic collision. Then we'll discuss inelastic collision. Okay, so let's see the perfectly inelastic collision. So what's that? So we have seen in case of perfectly inelastic collision, two things happen. One is the momentum is conserved. Okay, momentum is conserved. Then kinetic energy is lost. Okay, but two bodies stick together and move. This is an important thing. Two bodies stick together and move, and it makes it very, very simple, because just by applying law of conservation of energy, law of conservation of momentum, we can find out the final speed. Okay, we can just say m1 u1 plus m2 u2 is equal to, now because the two bodies stick together and move, so this is like one mass. Okay, so we have one mass moving with one velocity, so that is m1 plus m2 will be its mass, and velocity is suppose v. So just take that m1 plus m2 on the other side, so you get v is equal to m1 u1 plus m2 u2 divided by m1 plus m2. That's very, very simple, right, compared to that of the elastic collision. So this thing is clear. Okay, so V is just equal to m1 u1 plus m2 u2 divided by m1 plus m2. Okay, so this is very, very simple. Then we need to find out the loss in kinetic energy. So for that we take initial kinetic energy, that is half of m1 u1 square plus half of you can say the two bodies are moving, no, half of m2 u2 square. Okay, it will be half of m1 u1 square plus there is a mistake here, that's half of m2 u2 square, and then minus final kinetic energy. So minus final kinetic energy is that is half of m1 plus m2 multiplied by v square. Okay, so you put v is equal to m1 u1 plus m2 u2 divided by m1 plus m2 and you have square of that, and then what you do is you simplify this thing, this expression only, and finally what you get is delta K, means loss in kinetic energy in case of inelastic collision, is equal to this formula. You need to remember, it's half of m1 m2 divided by m1 plus m2 multiplied by u1 minus u2 square. Okay, so delta K is just equal to half of m1 m2 upon m1 plus m2 multiplied by u1 minus u2 square. Okay, now this thing m1 m2 upon m1 plus m2 has a name, specific name. It is called as a reduced mass. Okay, this thing is called as reduced mass. So if I call that reduced mass and I denote it by some letter, usually it is denoted by letter mu. So half of mu multiplied by u1 minus u2 square. So your formula becomes very, very simple to remember, right? So where mu is the reduced mass, mu is the reduced mass, okay, and what's that? m1 m2 divided by m1 plus m2. So it is reduced mass of two colliding bodies or any two bodies, right? So this thing is clear, everyone. Okay, loss in kinetic energy is half of mu times u1 minus u2 square. And what is mu? Mu is m1 m2 divided by m1 plus m2. Okay, is there any confusion? Okay, good. Then this was perfectly inelastic collision. So we got an expression for the speed and loss in kinetic energy. Then let's see elastic, sorry, we saw elastic, inelastic, perfectly inelastic. Now something which is in between the two, an inelastic collision but not perfectly inelastic. So for that one we have total momentum is conserved. Total momentum is always conserved in case of elastic, inelastic, okay, perfectly inelastic. Total momentum is always conserved. So you have m1 u1 plus m2 u2 is m1 v1 plus m2 v2. Then you have coefficient of restitution is equal to E, which is equal to v2 minus v1 upon u1 minus u2. Okay, and then from this one you can write down that v2 minus v1 is E multiplied by u1 minus u2. Okay, and v2 is equal to v1 plus E multiplied by u1 minus u2. And then what you can do is, okay, you can substitute that, you can substitute this thing, right? So till now there shouldn't be any problem, right? You can substitute this thing in this formula. Okay, so if you want v1 you will substitute for v2 sorry, if you want v1 you will substitute for v2 in this formula and you will get some relation, right? So you get these two relations, v1 is equal to this thing, v2 is equal to this thing. Personally I don't remember them and I think there is no need to remember, because now there are some chances that there will be a question based on collision. Okay, there are good chances, and there are very good chances that even without memorizing this formula will be able to solve it, okay, in almost about the same time. So if you want, if you are very good at memorizing, you can memorize this formula, okay, but I don't recommend personally to memorize, right? So this is okay, this is inelastic collision, but then there is loss in kinetic energy in case of an inelastic collision. So that is equal to delta Ke is equal to half of m1 m2 times u1 minus u2 square multiplied by 1 minus e square. So this is just similar to the last formula and it's not very difficult to memorize. So I will say that memorize this one, okay, remember this one. So delta Ke is equal to half of, you can say, mu multiplied by u1 minus u2 square, okay, multiplied by 1 minus e square, and you can memorize it this way. So delta Ke of inelastic is equal to delta Ke of perfectly inelastic multiplied by 1 minus e square, right? Delta Ke of inelastic is equal to delta Ke of perfectly inelastic, because this part is same, multiplied by 1 minus e square. So that way you can memorize it, okay. So now this you should memorize, because there can be a direct question just to find out the loss in kinetic energy, and then if we know the formula, it becomes very, very simple, okay. So this thing is clear, right? Okay, so then let us see some problems based upon this thing, okay. So let's see this problem. Two particles of masses m1 m2 move with initial velocities u1 and u2. On collision, one of the particles get excited to higher level I'm sorry, two particles of masses m1 m2 move with initial velocities u1 and u2. On collision, one of the particles get excited to higher level after absorbing energy E or epsilon, okay. If final velocities of particles be v1 and v2, then we must have, what should we have? Tell me. Okay, so just to give you an example, I can say they are saying different levels. So suppose you have an atom. In the atom you have one electron, okay. So now you might know this from the chemistry. So this electron is over here. So there is some energy level of electron, okay. So when electron revolves in first orbit, it will have energy level, let's say E1. When it moves to the second orbit, it will have energy level equals to E2, okay. It will come in physics also. So here the energy level would be E2. So now suppose some other particle, it might be anything, it might be a light particle, means photon, it might be another electron. So let's say another electron, okay, another electron comes and hits with this electron. So it gives part of its energy to this electron, okay, and it gets excited to the energy level E2, okay. So energy given is suppose E. So initially this one was moving with speed, let's call this one as u1, and this one moves with speed u2. So then this is simple, right? So energy of this one, this electron, plus energy of this electron, okay, this is initial energy, right? Okay, so that must be equal to final energy. Final energy is this one moves with velocity v1 in the second orbit, and this one moves with final velocity v2, okay, but then the energy difference between this level and that level is something, okay, right, and that energy difference is equal to epsilon or E that they are saying. Option A, what do you think? Option A is correct, right? Half of m1 u1 square plus half of m2 u2 square minus E is equal to half of m1 v1 square plus half of m2 v2 square. Okay, so we can think of it this way. So this first electron or first body, it has some potential energy, okay, it has some potential energy u1, let's say, right, when it's in first orbit or first energy level, plus its kinetic energy is half of m1 u1 square, okay, plus kinetic energy of second one is half of m2 u2 square, and that must be equal to potential energy of this one first particle in the second orbit, okay, u2, plus its speed in the second orbit half of m1 v1 square plus what, speed of the second one is v2, so its kinetic energy is half of m2 v2 square. And now you can move this thing u1 on this side, so what do you get? The potential energy difference between these two orbits, okay, so that is the energy required by this electron to move from this orbit to this orbit, and that is equal to what? That is equal to E, okay. So if you do u2 minus u1 and rest of the things will be same, right, rest of the things will be same, just put it over there. So half of m1 u1 square plus half of m2 u2 square is equal to u2 minus u1 plus this thing half of m1 v1 square plus half of m2 v2 square. Right, what is this thing? u2 minus u1, it's equal to E, so this is equal to E, the energy difference between two orbits, you can say, okay. This is an example. So yeah, you can move this E on this side, so option A becomes correct, right. But then I see option D also, it's the same thing. No, is it the same? Oh, they have written minus E on that side. Okay, option A is correct, right? So this thing is clear, everyone? Yes, no? Right. Is the example clear, Yamini? Okay, good. All right. So little bit of thoughtful question, you can say. All right, let's move on to the next one. Mass m moving horizontally along x-axis with velocity v collides and sticks to mass of 3m moving vertically upward with velocity 2v. The final velocities of combination is, tell me. A mass m moving horizontally along x-axis with velocity v collides and sticks with mass of 3m moving vertically upward. Okay, so what we can say is first mass was moving horizontally, okay, so its velocity is v, so its velocity is v I cap, right. Second mass was moving upwards, so its velocity is 2v, so let's say 2v times j cap, right. And then they collide and combine, so mass becomes, mass of this one was m, mass of this one was 3m, so total mass becomes 4m, and it moves with velocity v. So we can just say by conservation of momentum or we can just find write down direct formula. So what will be V bar? So it is just m1 v1 bar plus m2 v2 bar divided by m1 plus m2, and then we can just put the values. So it is m times v into I cap plus 3m times its velocity is 2v times j cap divided by m1 plus m2 is 4m. Okay, because they stick together, so this is perfectly inelastic collision. And then it's very simple, cancel out m. Okay, then you can take 1 by 4 outside, it is vi cap plus you have 3 times 2v. Okay, so it is 6. Oh, they have not written it explicitly like this. Okay, so 1 by 4 v times I cap, and this thing will be 2 by 4 means 1 by 2. Okay, so 3 by 2. So 3 by 2 plus 3 by 2 v into j cap. So that's the answer. So it is option B. Right? Option B. So this one is very simple. Okay. So if two bodies collide and stick, first of all, get happy. Okay, give yourself 1 second. Okay, to get happy, and then you solve. Right. So a metal ball. Let's see next one. A metal ball of mass 2 kg moving with speed of 36 kilometers per hour has a head-on collision with a stationary ball of mass 3 kg. After collision, both the balls move as a single mass. Once again, the same thing. Then the loss in kinetic energy. Okay, so first of all, we can get happy, right? Because they are moving with the same velocity, so they are sticking together. Okay, I mean they move as a single mass, so they are sticking together. So this is perfectly inelastic collision. So what is delta Ke? What's our formula? It's half of reduced mass multiplied by u1 minus u2 square. Direct question. Okay, so half of what is mu? m1 m2 divided by m1 plus m2. Okay, so you can directly write this formula multiplied by u1 minus u2 square. Now I told that this is reduced mass just to make it simple. Okay, but you can remember this thing also. So this is also simple, not that difficult. So it's half of m1 m2. So what is m1? 2 kg. What is m2? 3 kg. So 2 times 3 divided by 2 plus 3 is 5 multiplied by u1 minus u2. u1 is 36 and second is stationary, so u2 is 0. So 36 kilometers per hour. Okay, first of all, convert it to meters per second. So 36 multiplied by 5 by 18, this is 10 meters per second, right? So 10 square. So what is this thing? This is 10. 10 square divided by 10 is 10. Okay, 10 times 3 times 2 is 5. 5 times 10 is 50. Oh, 3 times 2 is 6. 6 times 10 is 60. I did 2 plus 3 instead of doing 2 times 3. So 60. 60 is the answer, right? Okay, this one is simple. Yes, no. Right, very, very simple. Okay. Then let's see the next one. A moving body of mass m and velocity 3 km per hour collides with a body at rest of mass 2m and sticks to it. Now the combined mass starts to move. What will be the combined velocity? So this is very, very simple. What's the combined velocity? m1 u1 plus m2 u2 divided by m1 plus m2. Okay, so m1 is m, velocity is 3 km per hour, and m2 is 2m, and it is at rest, right? Second one is at rest, and they stick together, so m plus 2m. So this is 3m, 3m, and m divided by m from here gets cancelled, 3 by 3 gets cancelled. So it is just 1 km per hour is the answer. It's option C. Okay, so this one was very simple. This is a very old question, but they can ask. It's not like they can't ask this question, right? Okay, so this one is very simple. Let's see next one. A body of mass 5 into 10 raised to 3 kg moving with speed of 2 meters per second collides with a body of mass 15 into 10 raised to 3 kg inelastically and sticks to it. So sticks to it, then loss in kinetic energy. So again the same question. This one is from Ames. So delta Ke is equal to half of m1 m2 divided by m1 plus m2 multiplied by, because second body is at rest, collides with a body, speed of second body is not given, so we'll assume that it is at rest, so speed of first body only. Okay, otherwise you will have u1 minus u2 square. So this is half of m1 times m2, so that is 5 into 10 raised to 3 is m1 multiplied by 15 times 10 raised to 3 is m2 divided by m1 plus m2 is 5 plus 15 means 20 into 10 raised to 3. Okay, and speed is 2 square, sorry, speed is 2, we have square of that. Okay, so 2 square divided by 2 is 2, then you have, okay, that 2 gets cancelled out with this 20 and 10 will remain in the denominator, so then you have 10 cube gets cancelled out, still 10 is there in the denominator, 15 times 5 is 75, 75 into 10 raised to 3 divided by 10, right? So then 75 into 10 raised to 3, options are in kilojoules, no, divided by 10. Okay, so everything is in kilojoules, so then 75 divided by 10 will give you 7.5. So it is 7.5 into 10 raised to 3 joules means 7.5 kilojoules. So it is option A, right? That's very simple. Okay, so actually it's the same question, right? Just value changed, so there is nothing difficult in it. Let's see next one. One object of mass 20 kg is moving with speed of 10 meters per second in west direction, and another object of mass 10 kg is moving with 15 meters per second in north direction. Okay, one object of mass 20 kg is moving with speed of 10 meters per second in west direction, and another object of mass 10 kg is moving with 15 meters per second in north direction. Both collide and stick together. Choose the correct alternative. Now you tell me. There, option C. Okay, let's check what is option C. Their momentum is conserved. Okay, they have okay, it should be there. All right, momentum is conserved and it is inelastic collision, so that's correct, right? It is option C. What are the other options? Their momentum is conserved and it is an elastic collision. It's not correct because they stick together, so it is inelastic. Kinetic energy is conserved. It's not conserved because they stick together, so kinetic energy cannot be conserved. The kinetic energy is conserved and it is elastic collision. Not correct, right? Option C is the answer. Okay, so very simple, direct question. Let's see next one. Two objects of mass m each move with speed u meters per second and collide at 90 degrees, then the final momentum is. So this one, assume collision is inelastic. So this is given. Assume that the collision is inelastic. Okay, so now what will be the final momentum? This is question. Two objects of mass m moving with the speed of u meters per second collide at 90 degrees. So now to find out final momentum, we don't need to assume anything, right? Because momentum is always conserved. Okay, momentum is always conserved. Yes, no? Is this thing clear? To find out the final momentum, it doesn't matter whether it's elastic, inelastic. If they say find out the final velocity, okay, then only it matters whether it is elastic or inelastic. Okay, final momentum means to find out the total final momentum, right? Because they are not asking about, yeah, now they are asking about the two combined objects, right? But if they just say the final momentum, so total final momentum is just equal to total initial momentum always. Okay, all right, so what will be total final momentum? Just equal to p bar is just equal to initial momentum, we can say. Okay, and two objects are moving at 90 degrees, so one you can say it's moving along x-axis, so its mass is m, velocity is u, but you can say it's u I cap. Okay, second mass is moving vertically upwards, suppose. Okay, they are moving at 90 degrees, so mass is m, speed is u, but you can say it's u times j cap. So total momentum is momentum of first one, that is m times u into I cap, plus momentum of second one is m times u into j cap. This one you can say is px, this is py. Okay, therefore what will be total momentum? Square root of px square plus py square. Okay, that is m times u square plus mu square, and that is square root of 2 times mu square. So just root 2 times mu. This is the answer. Okay, so this one is very simple, and I think you can just do it in mind. I mean, you don't need to write down any expression for this. They are moving at 90 degrees, mass is equal. Okay, and they are asking about the final momentum. So we know total initial momentum is equal to final momentum, and if two vectors are inclined at an angle of 90 degree, what is the resultant? Two vectors having equal magnitude inclined at 90 degree. It's just root 2 times magnitude of 1, right? So I think it shouldn't take any time. Okay, this thing is clear? Yes, no? Okay, not this thing. So this is very simple. What I am saying is it shouldn't take any time means this thing can be done in mind. Okay, two vectors are moving, I mean you have two vectors inclined at 90 degrees. Okay, and you just want the resultant, because total final momentum will be just equal to total initial momentum, right? So there is nothing in the question. Let's see next one. A body of mass 4 kg moving with velocity of 12 meters per second collides with another body of mass 6 kg at rest if two bodies stick together. So again there is nothing in this one. Then the loss of kinetic energy of the system is, okay, so delta k is half of m1 m2 divided by m1 plus m2 multiplied with u square. Okay, and most of the time second body will be at rest only. Okay, so this is just calculation. So what is mass of first body? 4, mass of second body is 6, so 4 times 6 divided by 4 plus 6 is 10 times u square is 12 square, right? So that is 144. Okay, so this is 6 times, this is 24. So 24 divided by 2 is 12, again 12 divided by 10. 144 times 1.2 is how much? This thing 172 or something like that. Yeah, it's 1.2 only, no? Yes, so option C. Okay, good, that is the answer, right? Let's see next one. Which of the following is not an example of perfectly inelastic collision? A bullet fired into a block, if bullet gets embedded in a block, is it perfectly inelastic or not perfectly inelastic? Tell me. Yes, it is inelastic. Capture of electron by an atom. Capture of electron by an atom. Then a man jumping on moving boat and a ball bearing striking another ball bearing. Option D. Yes. So two bodies are moving together perfectly inelastic. Okay, or more or less we can say perfectly inelastic. But here in option D, clearly a ball bearing striking with another ball bearing not perfectly inelastic, right? So it's option D. That question is very simple, right? Let's see next one. A ball falling freely from a height of 4.9 meter hits horizontal surface. Okay, a ball is falling freely from a height of 4.9 meters. It hits a horizontal surface. If E is equal to 3 by 4, then the ball will hit the surface second time after. Okay, this is the question. Ball is falling from some height. So let's say it's falling from some height and it hits the floor. Okay, height is 4.9 meters. Then E is equal to 3 by 4. So suppose it comes with speed u, it goes back with speed v. So what is the relation between v and u? So v by u is just equal to E, right? Because the ground is steady. You can say speed of ball is u1. Okay, speed of the ground is u2, initial speed, right? What is u1 minus u2? It is just u, because ground is steady, ground is not moving. Then after separation you can say that speed of ground is v2, so that is also 0, minus you have speed of the ball, so that will be equal to v1, but that's v. Okay, so there will be only sign difference here, so it will be E is equal to minus v by u. But again, the v is also what? The sign of v is opposite, right? So that takes care of this thing. Okay, this thing is clear. Sign of v is opposite, right? So there is negative sign. Okay, and the negative sign from here, it will get cancelled out. Okay, so E is just equal to v by u. Is this thing clear, everyone? Right, good. So E is equal to v by u, right? And then it is given to be equal to 3 by 4. Then the ball will hit the surface second time after. Now suppose it comes, hits the ground, and from this time, okay, so suppose this is t is equal to 0, then it comes back, it goes back with speed v, then it will go to some height. Okay, it will go to some height. So at that height, let's say its speed is v dash, that will be equal to 0, and again from there it will come back and hit the ground, right? So it goes like this and again it will come back. So it will again hit the ground with speed v only, so that we know. Okay, right? Because of conservation of energy till then. After that again its speed will decrease because coefficient of restitution is 3 by 4. Okay, but it rebounds, it has some speed, okay, which we can calculate from this formula. Then it goes to some height and again it comes back. Okay, so what is v? So v is just equal to E times u. Okay, we got that. And then using v dash is equal to v minus gt. Okay, v dash is equal to v minus gt, the kinematic equation, we can just say that v is equal to gt and t is equal to v by g, because v dash is equal to 0, right? V dash is 0, so v is equal to gt, and therefore t is equal to v by g. Okay, so that is equal to E times u by g. So this is time taken by the ball to go till this height, right? But we want time to come back, time after which it again hits the ground. Okay, so that will be 2 times of this time. Okay, we want, so we find this one, so it is E is 3 by 4, u is okay, let's find it. So t is equal to E is 3 by 4 multiplied by u is equal to what? Root 2 gh, and g is 10. Okay, so that is equal to 3 by 4 multiplied by root 2 GH is square root of 2 times 10 times 4.9. Okay, divided by you have 10. So 2 times 10 times 4.9. Okay, so what will be this thing? This will be 49 root 2, right? No, square root of 49 is 7 root 2. Correct, no? 3 by 4, 7 root 2 divided by 10. So that is this thing is 40. Or shall we take 9.8? I guess that will be simpler. 3 by 4. If we take 9.8 here, so 4.9 times 2 is 9.8. Then its square root, so it will become 9.8 square. Right? In place of 10, I will take g is equal to 9.8. Then you have 4.9. So this is 9.8 square. Right? 4.9 times 2. Okay, is 9.8. So then you have 9.8 and divided by 10. So here we can just cancel it out. Okay, we can forget about this. So 3 by 4 means 0.75. 0.75 seconds. But this is the time to go to that height, and then to come back again it will take another 0.75 seconds. So what's the answer? It's 1.5 seconds. Right? This is clear? Everyone? Okay, good. All right, let's see next one. In two separate collisions, the coefficient of restitutions E1 and E2 are in the ratio 3:1. In the first collision, the relative velocity of approach is twice the relative velocity of separation. Okay, so E1 and E2 are in the ratio 3:1. This is given. In the first collision, that's in E1, relative velocity of approach is twice the relative velocity of separation. Okay, so you have v2 minus v1 divided by u1 minus u2. So this is given that u1 minus u2 is equal to 2 times of v2 minus v1 in case of first collision. Okay, so this thing is just equal to what? Half then, because u1 minus u2 is 2 times of v2 minus v1. So this thing becomes half, right? So E1 is half. So then the ratio between relative velocity of approach and relative velocity of separation in the second collision is, so very simple. Okay, so E1 is half, so this is half times divided by E2, you have, this is 3 by 1. So move E2 on this side. Okay, 3 on this side, so E2 is equal to 1 by 6. But then you want ratio of relative velocity of approach. So this is velocity of separation divided by velocity of approach divided by velocity of approach, that's equal to 1 by 6, right? But you want velocity of approach to velocity of separation, right? You want relative velocity of approach to velocity of separation. So that is equal to 6:1. Okay, so answer is 6:1. Okay, nothing difficult, right? All right, so then that was very simple. Let's see next one. A body of mass 2 kg makes an elastic collision. Okay, elastic collision with another body at rest continues to move in original direction with 1/4 its original speed. The mass of the second body which collides with the first body is. Okay, so this is an elastic collision. So what is V1? V1 is just equal to m1 minus m2 divided by m1 plus m2 multiplied with u1. But is the second body at rest? Yes, second body is at rest. So that means we don't need to care about u2. Okay. So what is mass of the second body? This is the question. So very simple. What is v1? v1 is v1. v1 is 1/4. Sorry, v1 is 1/4 of u1. Okay, 1/4 of u1 is equal to m1 minus m2 upon m1 plus m2 times u1. Then u1 and u1 will get cancelled out, and then you have m1 plus m2 is equal to 4 times of m1 minus m2. Okay, so let's just simplify that. This is 4m1 minus 4m2 is m1 plus m2. Then you can move this 4m2 on this side, so it becomes 5m2 is equal to 4m1 minus m1 is 3m1, and therefore m2 is just equal to 3/5, 3/5 of m1. That is 3/5 of m1. m1 is 2. 3 times 2 is 6. 6/5 means 1.2. Right? This one is clear? Yes, no? So this is the answer. Okay. So not at all difficult if we know the formula, right? Let us try to solve this one. Two spheres A and B of masses m1 and m2 respectively collide. A is at rest initially and B moving with velocity v along x-axis. Okay. After collision, B has velocity of v/2 in the direction perpendicular to original direction. The mass A moves after collision in the direction. Okay, tell me. So two spheres A and B of masses m1 and m2 respectively. So A has mass m1 and B has mass m2. Okay, m1, m2, and they collide. A is at rest initially. Okay, so let's call this one as A because it is at rest. Okay, and B is moving along x-axis. So this is moving along x-axis with speed v. So let's say this is v times I cap. After collision what happens is B has velocity v/2. So this one has velocity v/2 in direction perpendicular to original direction. So this one moves like this, okay, with velocity v/2, and let's say this is j cap. The mass A moves after collision in the direction, so it will move in some direction. So now see, this one initially it had some horizontal velocity, so we can say for conservation of momentum in horizontal direction, it will have some momentum in horizontal direction, and there was no vertical momentum initially, but now this one has vertical momentum, so this one will have vertical momentum in reverse direction. Okay, is this thing clear? Yes, no? So this one will have some horizontal and some vertical momentum like this. So resultant will be something like this. Inclined to x-axis at some negative angle. Okay, so this is again m2, this is m1, and we want to find out m1 v1 bar. Okay, the mass A moves after collision in direction. So tell me, what we can say is just m2 times v into I cap, right? It's equal to here m2 times v/2 into j cap plus m1 times v1 bar, and then you can move this m2 on this side. Okay, and therefore you have m1 v1 bar is equal to what? m2 times v into I cap plus m2 times v/2, not plus, it will become negative, no, when it moves on other side, it will become negative. m2 times v by 2 into j cap, right? And then is some relation given between masses, two spheres of masses m1 and m2 respectively. Okay, no relation is given. Then v1 bar will be equal to, you have m by 2, m2 by m1, not m by 2, m2 by m1. So v1 bar is m2 by m1 multiplied with v into I cap minus m2 by m1 times v by 2 into j cap. Okay. So what's the answer? Tell me. You got v1 which is equal to this thing. So question is, it is A moves in some direction. What's the direction? So this is, you can say Vx, this is Vy. Okay. So we know theta, the angle made with the x-axis, is just tan inverse of V1y by V1x, right? Vy by Vx. So that is V1y by V1x. So tan inverse of V1y, what is V1y? Minus of m2 by m1 multiplied by v by 2 divided by v1x is m2 by m1 multiplied by v, right? So that m2 by m1 v gets cancelled, so it's minus half. So the answer is tan inverse of, theta is tan inverse of minus half, right? This thing is clear? Yes, no? So the answer is theta is tan inverse of minus half to the x-axis. Everyone? Okay? Right, good. So now see, we have solved some questions based upon collision. Okay, and you can see, if you know the formulae, all of the questions, I won't say most of the questions, except for there was some position vector question, right? There was some question, position vector based question. Yeah, this one. So except for this question, I think that every other question was very simple. Okay, so questions that are asked in the NEET are very simple. Okay, and we took some questions from other exams too. They're also very simple. So there will be some questions for practice. Okay, they might be as simple or they might be a little bit difficult, I don't know. Okay, but please try them. And the problems based on collision can be only solved if you have sufficient practice. Okay, if the questions are repeated, and there are great chances that questions are repeated. Repeated means values will be changed, and for inelastic collision they will find, they will ask you to find the loss in kinetic energy. So that is kind of repeated question. Okay, so if it is like that, or if they just ask you to find out final velocity, then that's very, very simple. But then now, if questions are based on coefficient of restitution, if body falls from this side, then it goes to this side, then what will be the time taken by it to come back, right, on the ground? So questions like this, so which are slightly different. So your mind will click only when you do sufficient practice, right? Okay, so we'll stop here. So this is end of collision and also this chapter, work, energy and power. On Monday we'll start with the next chapter, and tomorrow there will be a test based on laws of motion and work, energy and power.